The James Webb Space Telescope has simply sent Earth a monstrous admonition, and it's drawing nearer. This warning comes from the exoplanet Proxima b. With each new picture sent back, additional inquiries emerge, leaving specialists frightened. Each description from this far-off planet makes us wonder more about the secrets of the universe. Growing inquiries are emerging about a potential hostile planet close to Earth. Might there be an adjoining alien planet that has antagonistic goals? Could Proxima b ever represent a danger to our very existence? The subject of extraterrestrial life has captivated humankind for hundreds of years. However, with current technology like the James Webb Space Telescope, it has become an inquiry we can investigate more fully than ever before. Yet, the universe isn't making it easy to find answers. We continue to use our best tools, such as the James Webb Space Telescope, to catch glimpses of far-off planets and worlds, hoping to find clues that may point to life beyond Earth. However, let's be reasonable. Every new picture and piece of information reminds us of how little we truly know. While these discoveries could be monumental, they also highlight the immensity and intricacy of the universe, leaving us with more questions than answers. Grasping a distant planet like Proxima b could rethink our place in the universe. For researchers in astronomy, this is exciting, but for the general population, it often feels like just another piece of space news, far off, abstract, and at times overwhelming. These discoveries raise more questions than they answer, driving many to wonder how this affects life on Earth. Could Proxima b truly harbor life or even intelligent life that could one day present a threat to us? Regardless of the tremendous power of the James Webb Space Telescope, it can only show us so much. Sure, we've learned some unbelievable things, like the fact that we now have stunning new images of Proxima b, and we know that the universe is considerably bigger than we ever imagined. But still, what comes next? The viable implications of these revelations can feel as vast as the universe itself. Proxima b, discovered in 2013 due to its gravitational interaction with its star, was a significant scientific breakthrough for many researchers. Finding this exoplanet was like discovering a new large neighbor. Proxima b is just slightly bigger than Earth, and it orbits its star every 11.2 Earth days, making it an intriguing subject for further study. From a scientific perspective, the idea of a distant world so close to our own is thrilling. Yet, for most people, it's difficult to connect with a place that is 25 light-years away. To put that into perspective, even the fastest spacecraft ever built would take tens of millennia to reach it. Imagine what it might be like to stand on Proxima b. A star, Proxima Centauri, would appear as a dim red light in the sky, much cooler and darker than our sun. Proxima b orbits so rapidly that a year there lasts just a little over 7 Earth days. One side of the planet always faces the star, meaning it is permanently exposed to light, while the opposite side is covered in eternal night. It seems like something out of a science fiction novel, but the reality would be far harsher. On the bright side of Proxima b, any water would probably boil into steam due to constant exposure to heat. On the dark side, however, water would freeze into solid ice. The planet's star, Proxima Centauri, is also not a calm and steady neighbor like our sun. It throws out dangerous flares and intense radiation, making the surface of Proxima be a hazardous place for life as we know it. This isn't the kind of neighborhood where humans would want to camp out. Interest in finding life beyond Earth peaked in late 2020 when scientists detected a rare signal coming from the Alpha Centauri system, where Proxima Centauri is located. This signal had a unique frequency of 982.551 MHz, which grabbed everyone's attention. Such a signal could, in theory, be a sign of advanced technology. However, it is far too early to draw any conclusions. More recently, the James Webb Space Telescope has sparked even more excitement by suggesting that Proxima b could have water vapor in its atmosphere. Water, as we know, is a crucial element for life, and its presence could be a game changer. To better understand how much water is present on Proxima b, scientists are using advanced techniques like spectroscopy. This method allows them to detect the gases that surround the planet, acting as a cutting-edge investigative tool. By studying the planet's light spectrum, researchers can identify specific gases such as oxygen, methane, and carbon dioxide, which are all essential for life. Atmospheric modeling is another key strategy. By creating virtual simulations of Proxima's climate, scientists can make rough estimates about its conditions. These models serve a similar purpose to how paleontologists use dinosaur fossils to predict what ancient creatures might have looked like. However, the more we learn about Proxima B's atmosphere, the more we are reminded of the remarkable diversity of life that exists here on Earth. Extremophiles, for example, are tiny organisms that can survive in extreme conditions, boiling hot springs, acidic lakes, and the freezing cold of Antarctica. These hardy creatures show that life can adapt and thrive in conditions once thought impossible. Could life on Proxima B be just as resilient? The search for life on Proxima B presents enormous challenges, not only in terms of space travel but also in proving that life could exist in such a hostile environment. The planet is bombarded by intense space radiation, and its atmosphere may not offer much protection. Additionally, the distances involved are vast, meaning new kinds of propulsion systems are needed to make space travel to Proxima B feasible. Ideas like solar sails, particle drives, and even more theoretical concepts like warp drives offer exciting possibilities for future exploration. However, these technologies are still in their infancy and require extensive research before they can be used in real missions. While dreaming about future space travel is thrilling, we need to remain realistic. Finding life on Proxima B is fraught with technological and scientific challenges. Only by advancing our technology and expanding our understanding of the universe can we hope to unlock the full potential of distant worlds like Proxima B. This pursuit isn't just about satisfying curiosity. It's about pushing the boundaries of human achievement. Might we one day set foot on Proxima B or even make contact with life there? As we contemplate the long journey to Proxima Centauri and finding aliens, no longer does it feel bound to the realm of science fiction. Instead, it seems like a real, tangible possibility. This fascinating shift from a far-off dream to a scientific endeavor has attracted serious attention from cutting-edge organizations like Breakthrough Initiatives. These groups are committing tremendous resources to transform what would traditionally be an incomprehensibly long journey, one that could take several millennia using today's technology, into a mission achievable within decades. The goal of reaching another star system within a human lifetime has sparked innovation and optimism among mainstream scientists. However, these lofty aspirations are quickly tempered by the stark realities of our current technological limitations. Despite remarkable progress in space exploration, traveling to Proxima Centauri, even at just 4.2 light-years away, still presents enormous challenges. Current propulsion systems are simply not fast or efficient enough to make such a journey feasible in any reasonable time frame. Breakthrough Starshot, one of the most ambitious projects envisioned, uses powerful laser-driven sails to propel small spacecraft to speeds of up to 20% the speed of light. While this concept shows promise, it is still in the experimental stage and faces numerous technical and logistical hurdles. For example, it must overcome the dangers posed by space debris and ensure reliable communication over vast distances. The dream of reaching Proxima Centauri and possibly discovering alien life is closer to reality than ever before, but it remains grounded by the constraints of modern technology. Accelerating a spacecraft to near the speed of light with today's tools feels nearly impossible, like trying to solve a difficult puzzle in the dark. Even bold projects like Starshot, which aims to shoot a spacecraft toward Alpha Centauri using lasers, face significant practical challenges. The Earth's atmosphere causes disturbances for the lasers, making it difficult for space exploration tools to work with the precision needed. One proposed solution is the use of adaptive optics, smaller lasers on satellites that constantly monitor and adjust for atmospheric disruptions. This system would help powerful ground-based lasers remain focused on the spacecraft as it travels through space. However, the laser propulsion method requires a massive amount of energy, equivalent to the total energy consumed by the entire United States, and it would only work for a short time. Imagine setting up 100 million lasers over a vast area just to push a tiny spacecraft only 33 feet wide to 20% of the speed of light. At this speed, the spacecraft would still take 22 years to reach the Alpha Centauri system, a time span longer than many people's lifetimes. But the challenge of reaching Alpha Centauri isn't solely about overcoming technical obstacles. There are natural barriers as well. The gravity of the sun, the presence of space debris, and the sheer vastness of the distance involved all pose significant risks. Even communicating with a spacecraft on course for Proxima b would require sending messages through time. It would take about 4 years for a signal to reach it from Earth. Despite these overwhelming challenges, the desire to explore other star systems continues to grow. It is driven by humanity's deep yearning for discovery and exploration, rather than practical necessity. Even ambitious endeavors like Starshot, which aims to send a spacecraft toward Alpha Centauri using lasers, face many practical hurdles. However, overcoming these issues could revolutionize space exploration. Still, the potential risks involved, including communication delays and natural hazards, require thorough preparation. Despite the difficulties, many scientists believe the rewards far outweigh the risks. Finding life on Proxima b or another distant exoplanet continues to captivate minds around the world. Discovering life on another planet would be the most historic scientific breakthrough in human history. It would not only reshape how we see ourselves and our place in the universe, but it could also provide insights into the origins and ultimate fate of life on Earth. While humanity dreams of a future where we can travel to the stars, we are also taking practical steps in our search for life. The discovery of planets like Proxima b is just the beginning. Telescopes like Kepler have been crucial in identifying distant worlds that could potentially support life. By observing how these planets interact with their stars, either by blocking some of the starlight as they pass in front or by causing the stars to wobble due to gravitational forces, we can learn about their size, structure, and potential habitability. Now that Kepler's mission is complete, the James Webb Space Telescope is stepping up to take over. Its ability to detect infrared light allows it to study planets that were previously too faint or distant for us to analyze. As we learn more about Proxima b and other exoplanets, we are expanding our understanding of the universe, and with it, the possibility of life beyond Earth. The James Webb Space Telescope has opened new doors in the search for extraterrestrial life, especially with the discovery of exoplanets like Proxima b. While we are still in the early stages of exploring the potential for life on this distant world, the technology and curiosity driving us will continue to push the boundaries of what we know. Whether or not Proxima b harbors life, the journey to understand it has already reshaped our view of the universe and of ourselves. As we dig deeper into the mysteries of the universe, the quest for extraterrestrial life takes on new urgency and excitement. The advancements in technology, especially in observational space science, have enabled us to peer farther into the universe than ever before. Instruments like the James Webb Space Telescope are changing how we understand planetary systems, allowing us to explore the atmospheres of distant worlds and uncover potential signs of life beneath their surfaces. One of the most fascinating aspects of Proxima b is its location in the habitable zone of its star, where conditions could allow for liquid water to exist. This zone is often referred to as the Goldilocks zone, where temperatures are neither too hot nor too cold, creating a climate conducive to life as we know it. Scientists believe that if Proxima b has the right atmospheric conditions, it could potentially support living organisms, even if they differ greatly from those on Earth. Furthermore, the study of Proxima b opens a window into the processes that may have shaped life on our own planet. By examining the geological and atmospheric characteristics of Proxima b, researchers can gain insights into planetary development and evolution across different star systems. Such comparative studies could shed light on the processes that lead to habitability, offering clues about how life could emerge in other environments. Astrobiology, the field dedicated to the study of life in the universe, plays a critical role in this research. Experts in this field are not only focused on finding life but also on understanding its potential to adapt to extreme conditions. This knowledge could enhance our search for life in places once thought inhospitable, such as the icy moons of Europa or the methane lakes of Titan. The energy surrounding Proxima b is not just about the possibility of finding life. It also highlights humanity's intrinsic desire to explore and understand our place in the universe. As we consider the potential existence of intelligent life forms, ethical questions come into play. If we were to encounter extraterrestrial civilizations, how would we communicate with them? What protocols would we establish to ensure mutual respect and understanding? The societal implications of discovering life elsewhere are profound. Such a discovery could challenge existing beliefs and philosophies, prompting a reevaluation of humanity's role in the universe. It could also inspire a new era of cooperation as nations and organizations come together in a shared quest for knowledge and exploration. As humanity pushes the boundaries of space exploration, the drive to uncover the unknown intensifies. The discovery of exoplanets like Proxima b has sparked an unprecedented wave of interest in astrobiology, encouraging scientists to think more broadly about the potential for life beyond our solar system. While Proxima b remains one of the most studied exoplanets, the search for other habitable worlds is far from over. With the advancements in telescope technology and the refinement of detection methods, we are now capable of identifying planets in the habitable zones of distant stars with greater accuracy. New instruments, such as the James Webb Space Telescope, are allowing scientists to detect exoplanet atmospheres and search for the chemical signatures of life, such as oxygen, methane, and other gases associated with biological activity. This next-generation technology could revolutionize how we study planets outside our immediate reach. The possibility that there might be life or even intelligent civilizations on these distant worlds is slowly shifting from science fiction to scientific possibility. Yet, the reality of such discoveries brings challenges of its own. The ethical considerations around potential encounters with extraterrestrial life remain an area of intense debate. Questions about our approach to contact, the risks of contamination, and the implications for our understanding of life's origins must all be addressed. As our knowledge of the cosmos expands, so too does our responsibility to navigate the uncharted territories of space with caution, curiosity, and respect.